Hi everyone, welcome to the Bioinformatics Coach channel. In today's video, I'm going to show you how to remove human reads from viral sequence data. So let's get that. So before I proceed, let me say that the script for this tutorial is available. So if you want it, just check the description box. The download link to the script is there. I mean the script with the codes, all right, or the commands. All right, so let's get at it. Now for this tutorial, this is the requirement. You need to have conda or mamba or micromamba installed. That's the only thing. We will use one of these to install the packages, the tools we will use for this exercise. Instructions for installing them can be found in the description box. So let's get started. Now, this tutorial, I made it based on the original Galaxy tutorial. Let me just show you that one first. So this is the original tutorial. I will leave the link to this page in the description box. So what we are going to do is to reproduce the tutorial here, the instructions that have been given here. Now, let me say again that the command we are going to use, the codes, everything has been packaged into a single bash script. So if you want it, check the description box. The down link is there. You can use that to get the file that has the codes. Now let's proceed. So what we are going to do next is to set up our environment. That means we are going to install the tools we will use for this exercise. So let's move to the terminal and then do that. So on the terminal, I'm going to install the tools. I'll use Mamba, but you can use conda or micromamba also. So instructions for installing these tools can be found in the description box. So use any of them to set up your PC and then you can proceed. I'll use Mamba, by the way. So I'll create an environment and install the tools. I'll say Mamba create -n and I'll say NGS. This will be the name of my environment. And I'll specify channels. I'll say that C bioconda, dash C, conda forge, and then dash C defaults. These are the channels I'll use. And then I'll specify the tools. So I'll start with trimmomatic. And then I'll use BWA, I'll use some tools, and I'll use Seqtk. Trimmomatic will be used for trimming. BWA will be used for mapping. Some tools will be used for processing the BAM file that we generate, and then Seqtk will be used for subsetting the sequence that we generate, all right, the sequence data. So these are the tools I'll use. So I'm going to execute this command to install the tools. All right, Mamba has started this way. So let's wait for everything to get done for us. Okay, so Mamba has installed the tools, so we'll proceed. So what I'm going to do next is to activate this environment. So this is the name of the environment. Take note of yours and then activate it. So I'll clear the screen and then I'll activate it. So I'll say Mamba activate NGS. All right, so we have activated the environment. So now we can proceed with the activities. I'll clear the screen again and then continue. Okay, we are now ready. So what I'll do first is to create a directory and cd to it. That will be my working directory. I repeat, I am going to create a working directory and then cd into it. That will be my working directory. I always do that because I don't want to mix up files generated from different projects. Okay, so that's why I always create a working directory for every project that I do. So I'll say make the bara genomes. You can use any name of your choice, that's fine. And then I'll cd into it. And now I can proceed. So what I'm going to do next is to download the example data. So let's go back to the Galaxy tutorial page and then get the file. So on this page, scroll down to this side, get data. So click it and you'll be sent to this side. So you see getting the sequence data and you have your files here. Now here, they use 2 samples, but I'll use 1 sample. So that means I'll get just this one here. We are dealing with paired end, so I'll get this one. Now, if you have multiple samples, then you will need to add some additional commands so that all the files are processed. So if you have such a situation, you can always contact me. You can always book a session. I'll show you how to write codes to process multiple samples or multiple files. So my contact is in the description box. All right, so I'll download these two. So I'll start with this one. This one is just 2 links, so I'll just do it one by one. So I'll copy the link. Let me just make sure I've copied that link. So I'll just copy it, and then I'll move to the terminal. So I'll say wget, and then I'll paste the link there. You can use curl also to download, or you can even use your browser. All right, so the most important thing is to make sure you have the files. So I'm starting with the read one, which is the forward. So I'll execute this command to download it. So let's wait for everything to get done first. Okay, so we have the file here. It's a small file, 34 MB. That's for R1. So I'll also do for R2. So I'll copy the link, and then I'll paste it. So I'll say wget, and I'll paste it here. So this is my read 2. Okay, so we have downloaded the files. Let's take a look at them. So I have them here. So I have my paired end reads. Now I'll create another directory and then move them there. So these are the raw reads. So I'll say make the raw reads. And then I'll move the files. So I'll say mv star.fq.gz. And then I will move them to raw reads. Now if I do an ls, I'll find my directory called raw reads. And in that directory, I will have my files. All right, so I'm just trying to organize the file because we are going to generate other Fastq files. So we need to separate them. We need to differentiate the files. So these are the raw reads because we are going to process them. So this is how we do it. Now let's proceed. So we have our raw reads here. So the next activity is to trim the reads. All right, let's take a look at the instructions on the tutorial page here. Let's check. So when we are here, it says read, trimming, and mapping. So we are going to do the trimming, and then we will do the mapping. So we are starting with the trimming. Now, before I proceed, let me say that, let's go back to the read here. Now, if you have your sequence data, it's important to perform quality control. So it's important to assess the quality of the data before you do any processing, before you start the analysis. All right, you can use tools like Fastq Reads to do that. But for this tutorial, I'll skip that because the purpose of this tutorial, the focus of this tutorial is to show you how to remove the human reads. But if you have your own data, make sure to perform quality control, assess the quality, and then you can identify potential issues, and these issues you can resolve them before you start the actual exercise. All right. For this tutorial, I repeat, I'm skipping the quality control, but under normal circumstance, we are supposed to do that. So take notes. Now let's get back to the gallery tutorial page and look at what you're supposed to do. So we are supposed to do the trimming, which is here. So we will use trimmomatic to do this. So that's what we are going to do first, and then we will do the mapping. Now let's get back. So now with the instructions here, it says that we should use paired, and that's what we have. Then we should select this. I mean, all these things we are going to do it. And it also indicates that we have to use the default settings for the trimmomatic, the one on the Galaxy tutorial, the one on the Galaxy platform. All right, so we are going to use the default settings, and that is it. So we wouldn't do anything complex when it comes to trimmomatic in this tutorial. All right, so we will just keep it simple here. We are trying to follow exactly what has been given here. So that is what I'll also do. So let's proceed. So let's get back, and then we will continue. So we are going to trim the rate using trimmomatic. So if you are going to trim using trimmomatic and it's paired end, then you need to note that 4 files will be generated. All right, we will talk about that later. Let's also take a look at our raw reads, which are here. So the raw reads, if you want to specify them, you have to specify raw reads slash this and other stuffs here. So I'll do it this way. I'm going to create a bash script with the information I need, and then I'll also include a trimmomatic command, and then we'll have the trimming done for us. That will be much simpler to do. So first of all, I will take note of the sample name here, this one here, not the R1 and R2. I want just this one here. So I'm just taking note of it, and then I'll proceed. So I will create a bash script that has all the commands we'll use for trimming. So I'll say nano, and I'll say trim underscore reads.sh, and I'll open it. Again, the commands are all available. So check the description box, you'll find the link to the bash script. All right, so in this script, we'll first get our shebang line. We'll define it here. Sometimes you may not even need to specify it, but I will do it here. And then when I scroll down here, I'll do this. I'll first say make the trim reads, because the output will have to go to a separate directory. So that's the trim read. So I'm creating it first, and then the next line I'll define my reads. So read 1 is equals to raw reads, and then I'll indicate my sample name here. Now let me just confirm here. So let me do an ls into raw reads to see the file names. Yeah, so I have to add this to it. So I'll just do that here. It's supposed to be like this. Let me just clean it for you. Let me just go over it. I think that'll be better. So I'll just do it this way. So it's raw read slash this. I'll just copy and paste. That would be much easier. So this is read 1, and then read 2. Also raw read slash, let's just type it well, and then I'll just specify the file name for R2. So I'll just paste it here. That is for read 2. Now let's proceed. Now with trimmomatic, I earlier made mention that it generates 4 output files, and I've already covered a separate tutorial on trimmomatic, so I explain a number of things there in detail. So we are going to also define or specify those 4 files, I mean the names, and then we will feed it to trimmomatic. So I'll start with the first one, and that is, let me just do it here. So the first one is going to be output forward page, like this. Let's just type the name well. Yeah, so like this, forward page, like this, equals, and I'll specify trimmed underscore reads slash, I'll still need the sample name here, this one here, the base name here. I'll still need it because I'll use it here. So I'll just paste it, and I'll say dot trimmed dot paired, like this, underscore r1 dot fq dot gz. So notice this word here, trimmed. I'm just using it to describe the outputs. So this is for output forward paired. Now let's specify output forward unpaired. So the same, trimmed underscore reads, let's just correct it, trimmed underscore reads slash, and I'll bring my sample name. I'll just copy and paste, and that will be dot trimmed dot unpaired underscore r1 dot fq dot gz. Now let's also look at output reverse. So we'll have output reverse paired. Let's just type it well. So output reverse paired equals trimmed underscore reads slash, again I'll indicate my sample ID here, dot trimmed dot paired underscore r2 dot fq dot gz. And then we have to go to output reverse unpaired. So I'll type it. So equals trimmed underscore reads. And then I'll paste the sample ID dot trimmed dot unpaired underscore R2. It's R2. Let's do it well. So unpaired underscore R2 dot FQ dot GZ. This is the name for the output reverse unpaired. So now you have specified the output files. Just make sure that they are the same as what I have given here. All right, the paths should be given, and then you should also have the sample IDs and other stuffs. All right, so there's it. So now we are going to call trimmomatic. So to do that, I'll use this command. It's a simple command, by the way. So we will just say trimmomatic, and then we will specify the commands. So here we are dealing with paired and reads. So it's trimmomatic P. I repeat, we are dealing with paired and reads. So you call trimmomatic and you specify P. And then I'll also specify threads. So I'll say dash thread. And I'll say 8. You can also use 4, or you can use 6 or more. All right. So it depends on the computer you are using for the trimming. So I'm using 8 because I am not using a high-end PC. It's just my normal laptop. So I'm using threads 8. But if you're working on a server, you can increase this number so that the trimming process is done faster. Okay, for you. So that's what you need to know. Now I'm going to specify the read1, read2. So that will be $read1, $read2. And then I'll have to specify the output files. There are 4 of them. All right, so the 4 of them, putting all of them on a single line can be cumbersome. So I'll separate them. So I'll use this slash here. So this slash here means that the command here, the continuation is on the next line. That's what it means. So I can now move to the next line, and then I'll specify the output file. So I'll start with the output forward paired and output forward unpaired. So those are here. So I'll say dollar outputs. Let me just put it here. So the dollar is important. So dollar, and then you bring your output forward paired space dollar output forward unpaired, like this. We bring the slash again. We continue the next line. The next line will be dollar output reverse paired. Let's correct the paired. So it's paired like this. You should always check your typos. Okay, make sure everything is in the right order. And then our dollar output reverse unpaired. All right, that is it. Now we'll add something else. So let's do a slash and move to the next line. So the next line, we have to specify the sliding window. So I'll say sliding window like this. So sliding window, you bring your colon 4, and then you bring your 20. So this is the default setting on the Galaxy platform. That's why I'm also using it. All right, we can still check. Let me just check first before we proceed. So I'll just open the Galaxy environment now to see. Okay, so I have one open here. So this is one of my Galaxy platform activities. And so I'll just check for the default settings for trimmomatic. So I'll just come to the tools and search, because I want to reproduce what has been given on the Galaxy tutorial page. So I just want to confirm the sliding window. All right, so it's here. So it says 420. All right, so that's what I need, 4 and 20. Okay, so that's it. Now, by the way, before I proceed, let me say that I have tutorials on how to use the Galactic platform for bioinformatics analysis. An example is this one here. So I'll leave the playlist in that of those tutorials in the description box. So if you also want to learn how to use the Galactic platform, just use those tutorials to get started. All right, so now that we have confirmed everything, let's move to the terminal. So I have everything needed. So this is the final command for the trimming. Okay, we have specified everything here, so it makes things very easy and then simple. So we will save the changes and exit. So Control X, I type Y for yes, and then I'll exit it. All right. So now I'm going to execute this bash script to perform the trimming. So for the execution, you can use bash like this. Let me just type it. You can use bash. You can say trim_reads.sh. This will execute it for you, but you can also use this one here. Let me just show you. You can say /trim_reads.sh. But for this one, if you do it, you'll get an issue with permission. So you will need to do this first. You have to say chmod +x trim_reads.sh. Let's just do it here. And then you can say /trim_reads.sh like this. But I'll use this one here. So I'll say bash and I'll say trim_reads.sh. This is what I'll use. So I'm going to execute this command to trim the reads. So let's do that now. Okay, trimmomatic has started its work. So let's wait for the trimming to get done for us. All right, the trimming has been done. So you also have some summary here to help you get started with the files. So we can proceed. So now let's do this. Let's take a look at the output files. So I will clear the screen and continue. So if I do an ls, I'm going to find a directory called trim_reads. So in that directory, I'm going to see my output files. All right, there are 4 of them, but we are going to use the reads with mate space. That means we are going to use the paired R1 and paired R2. Those are the files we are going to use. So take note of that. So now we can proceed. Let's take a look at the next activity. Let's do this. Let's check here. Yeah, okay. So what we are going to do next is to map the reads to the human reference sequence, and that is the AG38 version. That's what we are going to do. Now, let me explain a couple of things here. We are dealing with a viral sequence data. So the sequence data were taken from human patients. And so it's likely that you have human DNA mixed with the viral sequence. All right. So that is why we are doing the mapping. So when we map the reads to the reference sequence, the reads that map to the AG38, those reads belong to humans. Those are human reads, human DNA reads. And so those ones are the ones that we will remove, we will filter, because we are interested in the viral sequence themselves. So hence the title, removal of human reads from SARS-CoV-2 sequencing data, because for this data, the human reads are contamination. All right, they are contaminants, so we have to remove them. That is not what we really want. We want the sequence for the SARS-CoV-2. We want the reads that belong to the SARS-CoV-2 organism. All right, that's what we need. So that is why we have to do the mapping. Let me just go back to the mapping. So with the mapping, we are going to use BWA to do this. And so what we need to do is to install BWA, which we have done already. And then we also need to get the reference sequence, the AG38. We need to get that, and then we can now perform the mapping. And by the way, I have a separate tutorial on mapping where I explain a couple of things in detail. So if you are interested, you can also watch that tutorial. The link to that video is in the description box. So let's proceed. So let's get back to the terminal. All right, we are on the terminal now, so everything looks good. So we are going to map the reads, which is this one and this one. That's the ones we are going to use. We are going to map them to the human reference sequence, AG38. We are going to use BWA, but we don't have the reference sequence here, so we need to also download that. So let's go to the page which has the file. So I have that here. This is a page, and I'll leave the link to this page in the description box. So when you are here, let me just go up first. So when you visit this page, just scroll down to the very bottom and you'll find all these files. So we want the AG38. I'll just enlarge it a bit because it's smaller here. Yeah, this should be fine. So I want the AG38. So that one is here, the Fastq file, by the way. I want the Fastq. So when you check this one, you will see ag38.fa.gz. That is what I need. So I'll download. So I'll just right click and get a link. I'll just copy the link. I'll just do it again. I'll just copy the link. And then I'll move to the terminal to download it. So on the terminal, I'll say wget, and then I'll supply it with the link. All right, so let's download it. So it's compressed, by the way, so it's about 1 gig or so, almost 1 gig. There's the file. So let's download it and then we'll proceed. Okay, the file has been downloaded. So let's do an ls. We are going to find it here. Okay, so we are going to do this. We are going to unzip it, or let me just say decompress it. That's what we are going to do. So I'll say unzip ag38.fa.gz. Now I'll execute this command to decompress it. It's a heavy file, so it will take some time. Okay, so the file has been uncompressed. So let's do an ls. We are going to find it's like this. What we are going to do is to move this file to another directory. All right, let's just clear the screen and do it again. Let's do an ls. So what we are going to do is to move this file to another directory. So I'll say make that ref. And then I'll move it there. So I'll say mv hg38.fa. It's a Fastq file. So I'll move it to ref. So now I'll do an ls. I'll find my directory ref, which is here. And in it, I'll find my reference sequence, AG38. So that's what you have. So now we are ready for the mapping. So with the mapping, we need our raw reads. Let me just go over again. I think I'll do it here. So we are going to perform the mapping using BWA. So we need our raw reads. So let's ls into it first, the directory which has the raw reads. So we need our raw reads, which you have this and this. We are dealing with a paired in data. We also need our reference sequence, which is here. So I'll say ls ref, and I'll find it. So my reads and then my reference sequence. So they are ready. So I can now start with the mapping. Now, if you are going to use BWA for mapping, you need to first index the reference sequence. So that is what we are going to do first. So I'll say BWA, and I'll say index, and I'll say ref/ag38.fa, and I'll index it. So let's execute this command. All right, so indexing has started. Take note that this file is heavy, so indexing can take some time. All right, so you have to be patient for the indexing to be done for you. Ideally, you should do this kind of work on a Linux cluster, okay, or a high-end PC, so that you don't get worried much about your PC being slow or something like that. So let's wait for the indexing to get done for us. Okay, the indexing has been done. So let's take a look at the output. Let's clear the screen first, and let's do an ls into ref, and we are going to find some additional files. So In addition to the FA, the .fa file, you have these files also generated. So now we are ready to perform the mapping. So let's continue. Okay, so let's take a look at our files one more time. So I'll say ls trim reads to look at the file. So I have my paired and reads. This is read 1, this is read 2. We can also say forward and reverse. I also have my reference sequence and I also have my index files, so we can proceed. So I'll now call BWA MEM to do the mapping. Now, if you take a look at the names here, the names are long. The file names for read 1 and read 2, they are long. All right. So if you specify everything on the terminal is going to be very busy. So I'm going to streamline some things here. So I'll define the read 1, read 2, and I'll also define the reference sequence, and then I'll call BWA MEM and supply the information to it. So I'll do this. I'll start with read 1. So I'll say read 1 equals trimmed underscore reads, and I'll specify the file name. So it's .trimmed paired. We are using the paired. So there's R1. Read 2 equals trimmed. I specify so there's paired R2. And then I also define the reference sequence. So that will be ref equals ref/hg38.fa. All right. Now we are going to create another directory called BAM. This is where we will store the outputs. So I'll say make the BAM. You can use any name of your choice, that's fine, but I'll use this one. So now I'll call BWA MEM. So I'll say BWA MEM, let me just do TS lowercase. Okay, so I'll call BWA MEM to do the mapping. So I'll say BWA MEM, so BWA space MEM, and I'll say -C, C like this, and I specify 8. This is number of threads. So I'm using 8 because I'm working on my normal laptop, but if you have a high-end PC, or if you are working on a Linux cluster, you can increase the number of threads. That will make it faster. Now let's specify the reference. So that will be $ref. And let's specify the read 1, read 2. So $read1, $read 2. So this is the final command for mapping. What we are going to do is to convert the output to a BAM file. So we'll add this to it. And we'll say some tools. We will use some tools to do that. So some tools view -h-b, and I'll say -o for outputs. And then I'll specify the file name as well as the directory. So I'll start with directory. So I'll say BAM's, it's BAM. We called it here. We specify BAM. This is the name we give to the directory. So it's BAM. So take note of that. So BAM/, and then I'll bring the sample name. I'll copy and paste, and I'll say .bam. You can also say .raw.bam. All right, that's also fine. It depends on how much processing you are going to do on the BAM file. So for this tutorial, we are just using a single BAM file. All right, so that's why I'm just giving it BAM. But if I was going to do further processes to generate other BAM files, then I'll add some sort of description. So I can say .raw.bam, or maybe .sorted.bam. I mean, just something to describe the BAM file that I would generate. But for this tutorial, I'll just use .bam. So that's it. And then I'll say dash here. It's supposed to be space and then dash. So the dash here means that the output here should serve as the input for some tools. So that's where the dash here comes. So dash is representing the output for this command here. All right, so now let's execute this command. Okay, so now mapping has started. So let's wait for everything to get done for us. Okay, the mapping has been done. So let's take a look at the output. So let's clear the screen first. Let's do an ls. We'll find our BAM directory. So let's ls into it. And we are going to find our BAM file. All right. So now we can proceed. Okay, so let's take a look at the next activity. So we will move back to the Galaxy tutorial page. So let's do that now. All right, so we are here. So after mapping, we have to obtain the identifiers of non-human reads. I repeat, after mapping, we have to obtain the identifiers of non-human read pairs. That's what we have to do. So non-human read pairs are read pairs that did not map to the reference sequence. That is AG38. We are dealing with a virus sequence data, but it's possible that we can have the sequences of other organisms present, and that is why the non-human phrase here is being used. Okay, so take note of that. So let's proceed. So let's scroll down. For some of the activities, I'll combine them into a single line. All right, that means I'll give you a one-line command that we can use, but I'll explain everything later on. For now, let's take a look at this one here. Read is unmapped, mate is unmapped. All right, so we are dealing with a paired end data. So what we want is that both reads, that is forward and reverse, both of them should not map to the reference sequence. Then we can select those reads. So those are the non-human read pairs. So take note of that. So I'll explain a couple of things later on, so don't worry. And then the rest of the stuffs here, I will just combine them. So we will do all that. So after doing all this here, we will get the identifiers, and then we will use Seqtk to get the data itself from the reads, the trimmed reads. That's what we are going to do. So let's proceed. So I'll move to the terminal, and then I'll continue. Now, before I do that, I also have to bring to your attention, especially for beginners. So here, the identifiers are the IDs that are in the Fastq files. All right. Now, this is how a Fastq file looks like. Let's just take a look at something here. I thought I'll explain this because some viewers may be beginners. So for Fastq files, a read, or let me just say a sequence, all right, we'll have 4 lines. We have the sequence ID, which begins with @ and we have the sequence itself, and we have this third line here, which is plus. Some will add other information there, and we also have the quality scores. This is how a Fastq file looks like. So what we want to extract is the seq ID. Now let's do that on the terminal before we obtain the identifiers themselves. So I will do an ls into the trim directory, and then I'm going to display the contents, some of the contents. I just want to display one record of it so that we will know what the Fastq format is, basically. So I'll use this command. So I'll say zcat, and then I'll say trimmed reads, and I'll specify this paired r1.fq.gz, and I'll now say head-n4. So every 4 lines represent a record. So I just want the first record. That's what I'm doing here. So there's the record. So we have the ID, we have the sequence, we have this other information, and we also have the quality scores. So it is this identifier that we want to get. We want those ones. We want the identifiers for the read pairs that did not map to the reference sequence. That's what you want. If you want all the identifiers here in this file, we can also do this. I think I'll just do it here. I'll say zgrep. So I'll say all lines that begin with @ like this, and then I'll specify it here. So this is paired R1. So I'll just list. So these are the identifiers that we are going to extract. Of course, we will not take all of them. We will only look at those that qualify to be non-human read pairs. So i.e. those that do not map to the reference sequence. So that's it. So let's go back to our other terminal and then start the activity. So what we are going to do is to use some tools to extract the alignment records for us. So the records will be those read pairs that do not map to the reference sequence. All right. So in the process of calling some tools, we will need to also specify what you call flags, right? Now, this is what we are going to. Let's go back to the Galaxy tutorial page. So we are using this criteria. Read is unmapped, mate is unmapped. All right, so we have to specify that. So with the flags, okay, there's a page here that explains the flags and how we can specify them, which is here. I'll leave the link to this page in the description box. You can read more about it. So this is the criteria. We have read. Let me just enlarge it. We have read unmapped, mate unmapped. Those are the ones we want. So with the flags for these two, we have 0x4, 0x8. So that gives us 0, 12. But here we have to convert everything to a hexadecimal value. I repeat, we have to convert everything to a hexadecimal value. So I'll do that. So don't worry. I'll show you how that is done. And then we can proceed. So that's basically about it. So let's go back. So we have our BAM file. So this is what we do. I will say some tools view. This is how we use some tools to extract alignment records. Then we can specify what we want. So I want, so that will be -f to include. So I will say 0xc. So the 0xc represents read is unmapped, mate is unmapped. That is what it represents. All right. And then we have to specify the BAM file itself. So the BAM file here, we have to say BAM/ and we specify the name. All right. So we will have this alignment records. Now, if you take a look at the Galaxy tutorial page, let's go back. Let's check. So that part is here. So we are supposed to save the output format as a Fastq. All right. And then we just want just the information for read one, but I will do everything. So that's the format. So for some tools, it's possible to also convert a BAM file to a Fastq format. So for that one, there's a command to do that here, which will combine. Okay. So for us, instead of saving this, we will just add this pipe command, and you see some tools Fastq. So this will convert the output here to a Fastq format. All right. But what we want is the identifier. That's what we want. All right. We want the identifiers themselves. And so what we have to do is to now issue another command to get the identifier. So with Fastq, all right, this what happens. Let's just look at it. Let's issue this command itself. With Fastq, this is how it is. Let's just do a head. All right, this is how the Fastq format looks like. But with what we have, we are going to select both the read one, read two. All right, but we want just the identifier. So that means we don't want duplicates. So here you can see this, and you can also see this, but we just want just this one. That's all that we need. So we will need to modify this command a bit to do that. So I'll now record the command again. All right, let me just clear the screen and do it again. So I'll record the command again. Let me just close these spaces. It doesn't matter. You can still leave the spaces there. It's fine. But I'll just close it a bit. So what I want is just the headers, the IDs. So I'll just say grep, and I'll bring this. This one will give me, let me just go over. This will give me the sequence IDs or identifiers in this Fastq outputs. All right. So let's execute this command. We are going to have something like this. All right. But still, we see 1 and 2. That is for read 1 and read 2. And we also see this. We don't want it. All right. Technically, you can still maintain this. It's fine. Okay, but we will just streamline the things here. So let's do this. So let's do an ls. Let's record the command again. And this time, that's what we are going to do. So after getting the grep, you add another command again, like this. And this time, that's what we are going to do. All right. We are going to use the awk command. Let me just do it here. I think I'll just leave some space here. That's fine. So we'll add an awk command. So that will be AUK. And I'll say -F. And then this is what I'll do. I'll bring a single quote. I'll bring a square bracket. And I'll say this and this. I'll bring another square bracket and I'll close it. So here I'm using two delimiters. You know, we have this and we also have this. All right, that's what I'm using. And then I'll bring a space and I'll bring another quote and I'll say curly brackets print. Let me minimize it. Let me just reduce the font size so that we can have everything on one line. Yeah, this should be fine. So print and I'll say $2 like this. Okay, so let's execute this command. So now you see what we get here. So these are the identifiers, but still there are duplicates. So we can remove the duplicates. All right. So let's do it again. Let's recall the command, and this time you add another command to it. All right. So I'll bring another pipe and I'll say unique, and that is it. Okay, so the unique will remove the duplicates. All right, let me just fine tune everything here. I think I'll still reduce the font size a bit so that we get them all on the same line. Let's see. Yeah, this one should work. Perfect. So this becomes our final command. So I can still work on it. So this becomes our final command. All right. So SAM tools view, and we select reads, that's the non-map, and also the made page with non-map. And then we will convert the records to a FASTA format, and then we will now get the identifiers or sequence IDs, and then we will remove duplicates. All right, so this is how it's done. So let's execute this command. Perfect. So now we have it done. So now you can see that there are no duplicates. All right, we have them here. But the information here, let's just clear the screen. Let's do an ls. We will have to save it to an output file. And then we will now use that output file as an input so that Seqtk will now do the subset for us. So that's what we are going to do next. So first of all, we have to save everything to an output file. So I will bring my greater than symbol. That one you know already. Let me just do this. Yeah, so I'll bring it here and then I will specify the output file. So the output file, you can give it a name of your choice. For me, I will say non_human reads.txt. And then I'll execute this command. All right, so now I'll execute it. So you may see something like this coming up, which I don't think is a problem. I got it myself. So if you get it, I don't think you should be worried much. We only want to extract the identifiers. So that's what I have here. So if I do an ls, I should see this file here, non-human reads.txt. So I can do a cat to display the contents. So that's what I have. So this here, these are the non-human reads. These are the reads that do not map to the reference sequence, and those are the ones we want. So we are now there. We are at the final stage. So let's continue. Okay, so let's do an ls again, and then let's proceed. So we are going to take a look at the next activity. That's going to be the last activity, by the way. So let's go back to the gallery tutorial page. So now we have obtained the identifiers for the non-human read pairs. So what we have to do next is to use those identifiers to extract the reads of interest from the original inputs. All right, so we are going to use Seqtk to this. And by the way, I have a separate tutorial on Seqtk. So in that tutorial, I gave a detailed explanation of how Seqtk can be used to subset sequences. So for this tutorial, I'll keep it brief. All right, so if you are interested in that video, you can check the description box for it. Now for Seqtk, this is the GitHub page. So you can also come here to read more about it and the usage. So that's what we are going to. We are going to use this command to do the extraction. So let's scroll down to it. Yeah, so we have this one here. So with our Fastq file, that's what we are going to. We are going to call Seqtk. We will say subseq, and then we will supply the Fastq file, and then the file which has the identifiers, and then we will direct to an output. So here we will do a slight modification. All right, so let's go back to the terminal. All right, so we are on the terminal now. So let's ls into the raw reads again, because that's what we are going to. We are going to extract the reads from the original files. All right, the reads of interest. So we are going to use the original files. So that's what I'm going to do. I'm going to write a bash script for this also. So that's what I'm going to do. I'm first going to create it, and then I'll edit the script. So I'll say nano, and I'll say subset reads. Or you can also say extract reads. Let's even use that one. So I'll say extract reads.sh, and then I'll open it. So I'll add my shebang line, and then I'll move to the next line. So in the next line, that's what I'm going to do. Let's just take a look at the files again there. Reads. All right. Now I'm going to create a directory called cleaned reads. So I'll say meta cleaned reads. And then the next line, I'll specify my command. So I'll do the Seqtk command for each of the reads. You know, we have paired end reads, read 1, read 2. So I'll start with the read 1. So I'll say Seqtk, and I'll say subseq, and then I supply that Fastq file, the read 1, which is here. Let's just look at it here. So this is it. It can be found in the raw read directory, but I'll just copy this one, and then I'll paste. So it's going to be raw reads / and then I'll paste the file there, and then I'll supply the text file which has the IDs, which is this one here, non-human reads.txt. All right, so that will also be here. And then I'll redirect everything to the cleaned reads. All right. Now, with what we have, okay, these are compressed Fastq files, but with Seqtk by default, you'll get a Fastq file which is not compressed, but ideally we should try to compress our files. So I'll add another command to do the compression for us. So that will be gzip. All right. So I'll do this. I'll say a pipe, and I'll say gzip, and then I'll redirect everything. So I'll say cleaned underscore reads / and then I'll bring my sample name here. You can use any other sample name, that's also fine, but I'll do it this way, and I'll bring it here. And then I'll also add a description. So I'll say .cleaned, and I'll say underscore r1.fq.gz. Now let me just make it smaller so that we can see everything on one line. Let's see. Yeah, this should be fine. All right, so we have our final command. So we have Seqtk subseq raw reads / we give the sample ID, and then r1, that's for read 1. We supply it with the text file with the IDs. We compress it. We direct the outputs to this one. We also give it a name. All right, so this becomes the final command for read 1. Now let's do same for read 2. So that will be Seqtk subseq raw reads / and I'll copy everything, So this time it's just copy and paste. So r2.fq.gz here is the same. Let me just do up to this point. And then cleaned with slash, and I specify my ID. I paste it there. Dot cleaned underscore r2.fq.gz. Let's just make sure that we have specified everything correctly. So we have that here. Let's see. All right, so this becomes the final command. Now let's add something else. I'll add some 2 lines. So here I'll say echo, let me just say extracting read 1. Let's extracting forward read. And then let's move to this line, echo extracting reverse reads. So that's it. So now let's execute this command. Let's save the changes and then execute the commands. So first of all, I'll add execution rights. So I'll say chmod plus X. I will specify the extract read.sh, that's it. And then I'll execute the command. All right, so I'll say dot slash extract underscore read.sh, and that's it. So I'll execute it now. You can also use bash and say extract read, that's also fine, but I'll do it this way. All right, so now it's working. So let's wait for everything to get done for us. Okay, the reads have been extracted. So if I do an ls, I'll find a clean read directory, and when I ls into it, I'm going to find my files. All right, so they have been done nicely. We can do a bit of exploration just to confirm. So I'll just say zcat clean reads this r1. I'll just do a head. I'll say head dash n4. Just to take a look at the first record. I have it here. I also do same for the read 2. So I'll just change this one here. I also have that done nicely for me. So I have everything here. All right, so we can see the corresponding data. All right, so that's how it is. All right. Okay, so this is how we remove human reads from various sequence data. Now, after cleaning your reads, one of the things you can do is to perform genome assembly and genome annotation. And I've already covered some tutorials on this. So if you're interested to know how to assemble various genomes and perform annotation, then check this video right here.